AI refers to AI systems designed to operate autonomously as agents, meaning they can perceive, decide, act, and adapt in pursuit of a defined goal. Unlike a regular chatbot that only responds to prompts, an agentic AI behaves more like a digital decision maker. It takes the initiative, manages tasks, and even sets sub goals without needing step by step human guidance. Think of it as a goal driven assistant rather than a simple prompt based responder. In short, generative AI creates content while agentic AI decides and acts on that content. This autonomy marks a key evolution in AI capabilities, laying the foundation for applications that can carry out complex objectives on their own. From a consumer's perspective, agentic AI is a game changer. Instead of just replying with information, an AI agent can take actions and complete goals on the user's behalf. For example, a platform like Cognosis urges you to give objectives, not just ask questions, because it can break down a complex goal into subtasks and accomplish them autonomously. This means everyday users could delegate tedious workflows. Think researching a topic, summarizing daily emails, or scheduling appointments, and have the AI carry them out end to end. The benefits are significant. It reduces manual work in complex workflows and enhances productivity by initiating and managing processes proactively. An age and tech AI assistant can work 24/7 with minimal supervision, handling tasks while you focus on more important matters. In short, consumers get a tireless digital helper that doesn't just inform them but actually does things for them, delivering a new level of convenience and efficiency. For developers, Agentic AI introduces a paradigm shift in the software development process. We are moving toward a world where AI can be a tireless, skilled teammate, capable of collaborating on code or even independently completing programming tasks for you to review. This changes the developer's role. Instead of hand coding every routine component, a senior engineer might delegate those tasks to an AI agent and focus on higher level design and problem solving. For instance, consider an AI coding agent that can plan and execute complex engineering tasks requiring thousands of micro decisions, recalling context at every step, and even fixing its own mistakes. Developers now need to orchestrate and supervise these AI driven workflows, becoming more of a conductor and code reviewer than a coder for certain tasks. New skills come into play: prompt engineering to specify what the agent should do, integrating the AI with developer tools or APIs, and setting up guardrails for the AI's autonomy. In practice, this can free developers from boilerplate and grunt work, allowing them to focus on more interesting problems while the AI handles repetitive tasks. The end result is faster prototyping and potentially more ambitious projects as human developers team up with AI agents to push software innovation. Agentic AI isn't just theoretical. Several projects have demonstrated its potential in the real world. One landmark example is AutoGPT, an experimental open source agent built on GPT-4. AutoGPT was one of the first systems to run fully autonomously, capable of taking a high level goal like launch an online business and then generating its own tasks from market research to writing code in order to achieve that goal. Its ability to operate without constant prompts showed how far an AI could go in pushing the boundaries of autonomous behavior. Another example, GPT-Engineer allows you to specify software in natural language, then sit back and watch as an AI writes and executes the code. In other words, it can generate an entire project's code base from a description and even run that code, iterating based on feedback, a huge step toward automating software development. On the commercial side, Devin from Cognition Labs is branded as the first AI software engineer. It's described as a tireless, skilled teammate that can work alongside you or handle tasks independently. Devin is equipped with the same tools a human engineer uses: a shell, code editor, web browser, all within a sandbox so it can plan, code, test, and debug in an autonomous loop. These examples, along with others like Rewind AI for personal life management or Salesforce's Einstein Copilot for business workflows, illustrate how agentic AI is already being applied. They show agents tackling everything from writing software to managing information, signaling that this approach is practical and here today. Implications. From a technical standpoint, building an agentic AI system is quite different from a standard single turn AI model. Architecturally, it's a looping system rather than a simple input output pipeline. A typical agent run involves steps like defining a goal, planning subtasks, using various tools or APIs, executing actions, observing feedback, and then iterating on its approach. The AI effectively controls its own flow of execution, making decisions on what action to take next. In fact, an agent can be defined as a system where an LLM, large language model, is used to decide the control flow of the application, such as choosing which tool to call or what step to execute next. This means, as a developer, you need to set up the AI with access to tools. For example, giving it the ability to call APIs, run code, query databases, or even browse the web depending on the task. Managing state and memory is also crucial. The agent should remember prior steps or relevant info, often achieved via vector stores or session memory, so it can handle long term objectives and not repeat mistakes. To build these systems, new frameworks and libraries have emerged. For instance, LangChain provides abstractions for tool usage, memory, and chaining LLM calls, making it easier to assemble an agent that can reason and act. There are also orchestration frameworks like AutoGen or Microsoft's Prompt Flow that help coordinate multi agent or multi step workflows. In practice, developers must design for autonomy. Your application might need to supervise the agent's actions, setting limits, verifying critical steps, while still letting the AI explore solutions. This blend of autonomy with oversight is a new software architecture challenge. Done right, it enables AI to handle complex tasks on its own, unlocking powerful new capabilities in our applications. Illustration spectrum of agent control from a simple router agent left making one-off decisions to a fully autonomous agent right that iteratively decides and acts. Agentic AI systems give the LLM much more control over the program flow, shifting from static scripts to dynamic AI driven orchestration. This requires robust design to ensure the agent's decisions remain aligned with user goals and safety constraints. Development. Slide. In conclusion, age and tech. AI represents the next frontier in AI powered software. It transforms applications from passive tools into autonomous agents that can carry out complex objectives. For end users, this means more powerful products. Imagine intelligent assistants that can not only draft an email or answer a question, but actually handle entire projects or routines for you. For developers, it opens up a new paradigm where we build co-workers rather than just static programs, AI entities that work alongside us, handle the mundane details, and even suggest creative solutions. Adopting agentic AI requires embracing new techniques and responsibilities in our development process, but it offers a huge payoff in capability. It's no surprise that by 2025, Agentic AI has become a priority in many enterprise AI roadmaps. As open source projects and frameworks continue to lower the barrier, we are likely to see an explosion of agent driven systems in everything from software engineering to customer service. For senior developers, especially those moving from traditional software into generative AI, understanding age and tech AI will be key to building the next generation of AI products.